Video is about electrolytes and thinking about what happens to substances when we dissolve them in water. So an electrolyte can be defined in a couple of different ways. The actual fundamental definition of an electrolyte is a substance that when you dissolve it in water is going to cause that solution to conduct electricity. And we'll see some videos in just a moment of examples of this. So what makes an aqueous solution conduct electricity? The only way that an aqueous solution can conduct electricity is by the movement of ions. And so therefore we can really redefine an electrolyte in terms of what's actually happening at the particle level. An electrolyte is a substance that produces ions when we dissolve it in water. So we're going to talk about examples of some things that are water soluble that are not electrolytes. We're going to talk about some things that are water soluble that are electrolytes. One of the first things we want to talk about is actually what happens when you dissolve something in something else. And so here is a sort of molecular depiction of dissolving methanol, which is an organic alcohol, in water. So here's a methanol molecule. Here is a methanol molecule. Here's a methanol molecule, and then you can see that there are water molecules here that are surrounding it. And so let's just talk about what are some basic terminology when we talk about solutions. A solution is a homogeneous mixture, and we talked about that in chapter 1 of two or more pure substances. There's no great magic to the definition of solvent and solute. The solute is simply any substance that is not there in the greatest amount, and the solvent is the substance that is present in the greatest abundance. And so in this particular solution of two substances, you only have two choices for the solvent. Water is there in greater amount, and so it is the solvent. Methanol is the solute. There's no other solvent. There's no other solute. What we would also point out about methanol here is that it is not forming ions. Methanol consists of methanol molecules, and when you dissolve them in water, they stay intact. And so that is not going to ionize when you dissolve it in water. If you take an ionic substance, and here's an image of a sodium chloride crystal, and you dissolve that in water, it's interesting to think about, well, what's happening if I take salt and I dump it into water? You know, this happens all the time in cooking pots and stuff on the stovetop. And that salt goes into solution. What's actually happening is that the water molecules are coming around and surrounding the individual ions and separating them from the crystal. And so here you can see some water molecules surrounding a sodium ion. Here you can see some water molecules surrounding a chloride ion. And you can see that they all just diffuse away from each other. And so when you dissolve sodium chloride in water, unlike methanol, which gives you intact molecules, dissolving sodium chloride or another ionic substance is going to give you this collection of ions in solution. And that process of being separated from the crystal and surrounded by water molecules when it dissolves is called dissociation. So an electrolyte is going to be a substance like sodium chloride in which when we dissolve it in water, it dissociates into ions. So here's the first slide was my definition of an electrolyte. Here's the textbook's definition of an electrolyte. An electrolyte is a substance that dissociates into ions when dissolved in water. And so sodium chloride would be an example of that. A non-electrolyte is something that, although it dissolves in water, it does not dissociate into ions. And so methanol is going to be here our example of that. So we can also categorize electrolytes as being strong or weak, and that's a lot to kind of have to pile onto the definition here. But you're going to see examples of this in a video in just a second. A strong electrolyte is going to be something that produces a large abundance of ions when you dissolve it in water. A weak electrolyte is going to tend to be something that produces ions, but in relatively small quantity when you dissolve it in water. And then a non-electrolyte is going to be no ions. And so I have a little flow chart that I'm going to show you at the end of this to help you help you make decisions about categorizing certain things. But ionic compounds that are soluble in water are going to be strong electrolytes. Molecular compounds, and again, we go back to methanol as an example, are going to tend to be non-electrolytes, except for acids. I'm not really going to talk about molecular bases in this video, but we will talk about acids and what happens to them in solution. Okay, let's watch a couple of videos that just kind of give you an indication of what we're talking about here.
Oh, hi! Today we're going to learn about solutions and how they conduct electricity, or don't. Tap water. Distilled water. Huh? What? Salt water. 1 teaspoon per cup. Ooh. Hydrochloric acid. Nice. Sodium hydroxide. Ooh, just as concentrated. Sugar water. Sweet. Vinegar, a weak acid.
See, the weak acid only lights the bulb slightly, whereas
Ethanol, a dissociative that doesn't dissociate. Don't try this at home. Barium sulfate. It's insoluble. No conductivity here.
Okay, let me go back and pull a different video here. This one's not quite as exciting, but it kind of tries to reinforce the same thing.
The term electrolyte is a term used when talking about solutions with water as the solvent. We'll demonstrate the property of being an electrolyte with an electrical conductivity tester like this. Pure water does not conduct electricity. I will put the electrodes of the apparatus into the beaker of water. There's no light coming from the light bulb. If I dissolve a material in this water and the light lights very brightly, the dissolved material is called a strong electrolyte. As an example, here is a small amount of table salt. I'm going to add just a little bit to the water and stir it up. As it dissolves, the ions of sodium and chlorine, which are charged particles, go into the water, which will now allow the solution to conduct electricity. So the ionic substance, table salt or sodium chloride, is a strong electrolyte. The term non-electrolyte refers to a substance which dissolves in water but does not allow electrical conductivity. Here is some sugar, which I will dissolve in the water. As the sugar dissolves, the light does not light up. So sugar is a non-electrolyte. Some acids and bases are also strong electrolytes.
Okay, that's enough of that video. Here's just kind of an image from your textbook that shows the same thing that last gentleman was doing. If you try and light the light bulb with pure water, you don't get conductivity. If you try and do it with sucrose, it doesn't conduct electricity, but if you do it with sodium chloride, it does. Again, here's this issue, this distinction between a strong electrolyte and a weak. A strong electrolyte is something that dissociates or ionizes completely when you dissolve it in water. A weak electrolyte is going to be something that only dissociates or ionizes a little bit when you dissolve it in water. So, what are the strong electrolytes? Strong electrolytes are going to be soluble ionic salts. So like sodium chloride, like magnesium chloride, like ammonium sulfite, any water-soluble ionic salt. Strong bases, and really the strong bases are just hydroxides, and because they are also ionic compounds, they really just fall under this idea of soluble ionic compounds. And then strong acids, and later in chapter 4 we'll talk about what the strong acids are. Here's a list of them, but we will talk about them. Them again a little bit later. What I wanted to do was just show you this little flow chart that I made, and so this is just kind of here to help you categorize whether or not a thing is uh, a strong, weak, or non-electrolyte. So we're going to start with just any substance, and the first question is it soluble in water? And if it's not, it's going to be a non-electrolyte, because the definition is that it's a substance that when you dissolve it in water creates ions in aqueous solution. So actually, at the very end of that first video, you noticed that he had barium sulfate, which is an ionic compound, but because it is just completely insoluble in water, it did not conduct electricity at all. So if the thing's not soluble in water, it is not an electrolyte. If it is soluble in water and it's ionic, then that makes it a strong electrolyte. And again, that's going to encompass just about any kind of ionic compound we've talked about so far in this class. Sodium chloride being the most obvious example, but any other sort of combination of ions that we've talked about so far this year. If it's soluble in water, it's going to be a strong electrolyte. If it's not ionic, then that means it's molecular. And so then you have to just ask yourself the question, is it an acid? And if it's not, and things like methanol and ethanol and acetone and sugar are things that are not ionic, they are soluble in water, they are not ionic, they are not acids, and so they are non-electrolytes. If it is an acid, that is now a molecular compound that is soluble in water and is an acid. Then you'll have to ask yourself the question, is it a strong acid? And if the answer is yes, it's a strong electrolyte. If it is not, it's a weak acid and it's a weak electrolyte. And again, in that first video, there were examples of this. There was hydrochloric acid, which is a strong acid, and so it was a strong electrolyte. And then there was acetic acid or vinegar, which is a weak acid, and so it only lit the bulb up slightly. So let's try some examples, say a question you might get on a QOD about this. And in fact, I just decided to take some examples from our experiment in which we made sulfuric acid. So here's one of our starting materials, sodium nitrate. And so we're just going to go down the chart here. Is sodium nitrate soluble in water? Well, what you're going to learn in just a few more days in this course is that anything that's got sodium cation in it or a nitrate anion in it is soluble in water, and so sodium nitrate certainly is. Is sodium nitrate ionic? It is. Therefore, it's a strong electrolyte. Let's try our other reactant from the experiment that we did to make sulfuric acid, sulfur. Sulfur. Is sulfur soluble in water? The answer to that question is no. Sulfur is not water soluble, and therefore sulfur is a non-electrolyte. Let's try a couple more. The product of our lab reaction. So is it soluble in water? It is. Sulfuric acid is soluble in water. Is it ionic? It is not. It's a molecular substance made up entirely of nonmetals. So we're going to keep coming down here. Is it an acid? It is an acid, so we're coming down here. And as it turns out, sulfuric acid is on the list of strong acids, and therefore it's a strong electrolyte. Finally, we'll look at glucose. We've talked a lot about glucose in the context of empirical formulas. So we start up at the top again. Is glucose soluble in water? It certainly is. Is it ionic? It is not. It's made up entirely of nonmetals, and there's no obvious cation or anion here. Is it an acid? It is not an acid. And by the way, how do you know if a thing's an acid? Generally because it's going to have an H on the front of its formula, and sulfuric acid is a great example of that. Therefore, having come all the way down here, glucose is a non-electrolyte. Okay, what's the point of all this? What's the point of categorizing things as electrolytes, either strong or weak or non-electrolytes? The point is that As we get further into this chapter and talking about reactions that occur in aqueous solution, we really need to get you to think about what's happening when various substances dissolve in water. And so, because there are a lot of things that will dissolve in water, but depending on what the substance is, what's actually happening at the particle level will vary from substance to substance. So just because a thing is soluble in water doesn't mean that that makes it the same as something else that's dissolved in water. Salt and sugar are great examples of this. So some compounds dissociate when you dissolve them in water, and the example of that would be ionic compounds. Some substances ionize when you dissolve them in water, and that would be acids. So acids, when you dissolve in water, although they are molecular compounds before they go in, they will ionize to produce hydrogen ions and as well as anions in aqueous solution. And finally, some substances don't produce ions, and those would be non-electrolytes. So hopefully I've given you an idea of what we're talking about here. I've given you some examples of things you might see on a QOD. Thanks so much for watching.